1, 2, 3, 4. It's happening. And I will send myself a heart. Okay, whatever. You just close the dockable window. If you would like to show it again, use the docks menu on the menu bar. Thank you. All right, here we go. Fourth streaming session of learning Python for everybody. But it doesn't mean that it's my first actual session since sitting down, since the last streaming, because I did try and did something during work. I guess it's good to mention the breakthrough. I had a very nice, let's say, realization, small, what am I doing? Small progress. And that was when there was the exercise. It was the exercise to create a function to basically rewrite my program, which takes your salary, basically the compute pay, and how to put this into a function. I was really stuck. I was really stuck. But yeah, compute pay. Here we go. And basically, it was an interesting experience because I really felt lost. Like I just couldn't, I didn't want to use ChatGPT or anything. And then there was a what if moment. Like, what if I just put the calculation under the function and then everything else I will just add, and it does work. So, and that was a really nice moment. However, there's still a lot to go, so I have to just continue. So yeah, yesterday I took my 1 hour lunch, and really I tried the Pomodoro, I think it's called Pomodoro technique. So 25 minutes paying attention and 5 minutes break, 25, and 25 again, and that was for the whole day. And basically it's not sustainable. If it's just 1 hour a day, it's gonna progress very slowly. So I have to really I have to use my PLT. I can use my learning time. We can schedule something. Basically, we need at least 1.5 hour every day during the day, and something in the evening. Can you see the cat? See, there's the cat. The other way. Here's the cat. Okay, let's do it. So I'm gonna just put it's on. The watch is on do not disturb. Nobody's gonna disturb us. And I'm just gonna put 25 minutes, then break, and we're gonna repeat this cycle. I want to do it 4 times, no, 6 times, yeah, until 6 p.m. And I took 50 milligrams of Ritalin for the record. Just now, so at 2:34. I'm so nervous. I'm not nervous actually. I'm just extremely moody. I went to gym. 1-2-3. I'm gonna try to. Yeah, the gain. Is the gain now too much? Yeah, probably like this. 1, 2, 3, 4. Okay, maybe this is too much. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. I'm gonna put this closer. Do you hear me, Gergely? Do you hear me, Gergely? Hello. Okay, so this is fine. This is gonna be the best one. Yeah, I will just use this. I don't know, I guess it's not gonna be okay like this. I'm gonna 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, with this out of the way, let's do it. Cool. Yeah, I was able to use I'm using the desktop PC now. The laptop was getting really slow during the stream. It was getting really heavy on it. But I have a beast here, so this shouldn't be a problem. But I'm using the iPhone 5S, I think, or what is this, for camera, and I will figure this out. I couldn't resize so I have these nice black bars now, but we're just gonna have to take it. So, where are we? Yeah, so I'm gonna go through again chapter 5 iterations. I've been through this at work, but repetition is the key. Is there a nice repetition is the mother of learning. Repetition is the mother of learning. Updating variables. A common pattern in assignment statement is an assignment statement that updates a variable where the new value of the variable depends on the old. This means get the current value of x, add 1, and then update x with the new value. If you try to update a variable that doesn't exist, you get an error because Python evaluates the right side before it assigns a value to x. Before you can update a variable, you have to initialize it, usually with a simple assignment. Updating a variable by adding 1 is an increment, subtracting a 1 is called a decrement. Okay. The while statement. Computers are often used to automate repetitive tasks. Repeating identical or similar tasks without making errors is something that computers do well and people do poorly. Because iteration is so common, Python provides several language features to make it easier. One form of iteration in Python is the while statement. Here is a simple program that counts down from 5 and then says blast off. So yes, we did this code, and I tried to use the pencil I have, which I bought from my last trigger or like impulse purchase. It looks bad. It looks hideous. It's not great. But maybe I will get an iPad eventually. Maybe I will get an iPad. Who knows? Maybe if I'm out of PIP, I will just celebrate to get an iPad, because why the fuck not? I have so much money. You can almost read the while statement as if it were English. It means while n is greater than 0, display the value of n, and then reduce the value of n by 1. When you get to 0, exit the while statement and display the word blast off. More formally, here is the flow of execution for a while statement. Evaluate the condition yielding true or false. If the condition is false, exit the while statement and continue execution at the next statement. If the condition is true, execute the body and then go back to step 1. This type of flow is called a loop because the third step loops back around to the top. We call each time we execute the body of the loop an iteration. For the above loop, we would say I had 5 iterations, which means that the body of the loop was executed 5 times. The body of the loop should change the value of one or more variables so that eventually the condition becomes false and the loop terminates. We call the variable that changes each time the loop executes and controls when the loop finishes the iteration variable. So this is good that we are here again, because yesterday there was an iteration variable when we were checking the for. So the iteration variable it changes and controls the loop. Iteration variable, which can be named everything, and it can be used during the while state, like basically during the iteration process. If there is no iteration variable, the loop will repeat forever, resulting in an infinite loop. Yeah, I'm just commenting this because yesterday when I was checking this code, is it still working? When I was checking this code, I was kind of like confused, like where is this friend is coming from? Why is it now or something? And friend is an iteration variable, the loop. Yeah, whatever. An endless source of amusement for, yeah, I read this line so many times, but I understand it. So this was actually something confusing to me, because in the case of countdown, we can prove that the loop terminates because we know that the value of n is finite, and we can see that the value of n gets smaller each time through the loop. So eventually we have to get to 0. In the case of countdown, so I think he refers this because it's a countdown, right? The counts down from, yeah, absolutely. So because this was not obviously named countdown before, but he refers to this one. We can prove that the loop terminates because we know that the value of n is finite, and we can see that the value of n gets smaller each time through the loop. So eventually we have to get to 0. Other times a loop is obviously finite because it has no iteration variable at all. Sometimes you don't know it's time to end a loop until you get halfway through the body. In that case, you can write an infinite loop on purpose and then use the break statement to jump out of the loop. This loop is obviously an infinite loop because the logical expression and the while statement on the while statement is simply the constant true. Man, I'm cold. I'm actually cold. I'm gonna get a... Oh my god. Look at this guy. Look at this guy. Not a single problem in the world. Not a single problem. Not a single problem. I will be right back. All right. Wow. This hoodie is extremely wrinkled and smells like shit. This loop is obviously an infinite loop. Yeah, okay, we know this. If you make the mistake to run this code, it will run forever. While this is a dysfunctional infinite loop, we can still use this pattern to build useful loops as long as we carefully add code to the body of the loop to explicitly exit the loop using break when we have reached the exit condition. For example, suppose you want to take input from the user until they type done. You could write while true line equals, yeah. We assign, yes. Where is it? While true is the statement, the condition which runs forever. Then we're gonna add line, we're gonna assign. This is a variable, I hope so. We can check. Where is my Visual Studio Code? Okay, I'm gonna just delete all of this again. We have to do it like this. Cool. Yeah, it's a variable. So the point of this is that you can use the break when we have reached like so there's beneficial to run to have a partially infinitely running loop, because then you have the option to break it. So in this case, in this code, it can ask for input until there's a certain condition is met, which is done. The way of writing while loops is common because you can check the condition anywhere in the loop, not just at the top, and you can express the stop condition affirmatively, stop when this happens, rather than negatively. Finishing iterations with continue. Sometimes you are in an iteration of a loop and you want to finish the current iteration and immediately jump to the next iteration. In that case, you can use the continue statement to skip the next iteration, skip to the next iteration without finishing the body of the loop for the current iteration. Here is an example of a loop that copies its input until the user types done, but treats lines that start with the hash character as lines not to be printed. While true, line equals input. So here the line 0, it's something which I asked ChatGPT to tell me because I was wondering. And the line 0 is used to access the first character of the string line. Come back. Okay. All the lines are printed except the one that starts with the hash sign, because when the continue is executed, it ends the current iteration and jumps back to the while statement to start the next iteration, thus skipping the print statement. Sometimes we want to define loops using for. Okay, just to understand. So what did we learn from these so far? Is that you can use continue statement. It's a statement which will go back, like if it basically repeats the same iteration, and won't basically it won't print in that case what you wrote. And if you want to exit from an infinite loop, you can use break. And what can you do? The while is also a loop, basically. I mean, it's while something happens, evaluate the condition yielding true or false. If the condition is false, exit the while statement and continue execution of the next statement. If the condition is true, execute the body and then go back to step 1. It's a loop. Yeah, I'm gonna throw this out. Sometimes we want to loop through a set of things, such as list of words, the lines in a file, or a list of numbers. When we have a list of things to loop through, we can construct a definite loop using a for statement. We call the while statement an indefinite loop because it simply loops until some condition becomes false, whereas the for loop is looping through a known set of items, so it runs through as many iterations as there are items in the set. The syntax of a for loop is similar to the while loop in that there is a for statement and a loop body. Everything in its right place, right place. I woke up today sucking on a lemon. Never mind. Sometimes we want to loop through a set of things such as a list of words, the lines in a file, or a list of numbers. When we have a list of things to loop through, we can construct a definite loop using a for statement. We call the while statement an indefinite loop because it simply loops until some condition becomes false, whereas the for loop is looping through a known set of items, so it runs through as many iterations as there are items in the set. The syntax of a for loop is similar to the while loop in that there is a for statement and a loop body. In Python terms, the variable friends is a list of 3 strings, and the for loop goes through the list and executes the body once for each of the 3 strings in the list, resulting in this output. Translating this for loop to English is not as direct as the while, but if you think of friends as a set, it goes like this. Run the statements in the body of the for loop for once each friend, in the set named friends. Looking for the for loop for looking at the for loop, for and in are reserved Python keywords, and friends are variables. In particular, friend is an iteration variable for the loop. The variable friend changes for each iteration of the loop and controls when the for loop completes. The iteration variable steps exclusively through the strings stored in the friends variable. Okay, so we can finally do some more notes, new notes. Loop patterns. Often we use a for or while loop to go through a list of items or the contents of a file, and we are looking for something such as the largest or smallest value of the data we scan through. These loops are generally constructed by initializing one or more variables before the loop starts, performing some computation on each item in the loop body, possibly changing the variables in the body of the loop, looking at the resulting variables when the loop completes. We will use a list of numbers to demonstrate the concepts and construction of these loop patterns. Often we use a for or while loop to go through a list of items or the contents of a file, and we are looking for something such as the largest or smallest value of the data we scan through. These loops are generally constructed by initializing one or more variables before the loop starts, performing some computation on each item in the loop body, possibly changing the variables in the body of the loop, looking at, I don't have literally brain now, but okay, we will try again. This is why we are here, it's okay. This is the good thing about programming and Python. It doesn't care how you feel, really. Like this whole concept, it's not about emotions. It's literally, it's gonna, just know things and they are working. It's not gonna care, and it get things done, right? So fuck it. Often we use a for or while loop to go through a list of items or the contents of a file, and we are looking for something such as the largest or smallest value of the data we scan through. These loops are generally constructed by initializing one or more variables before the loop starts, performing some computation on each item in the loop body, possibly changing the variables in the body of the loop, looking at the resulting variables when the loop completes. Okay, 30 seconds. So how about I'm gonna just make a note, like I'm gonna note all of this down, and then the 5 minutes. Performing some computation on each item in the loop by possibly changing the variables in the body of the loop. Counting and summoning loops. Okay. So now 5 minutes. And I'm gonna throw this tea out. I need to go to therapy again, honestly. This is HDMI. Okay. I lost my mouse. Counting and summoning loops. For example, to count the number of items in a list, we would write the following for loop. Count equals 0. For iter var in 3, 4, 1, blah, blah, blah. Count equals count plus 1. Count. We set the variable count to 0 before the loop starts, then we write a for loop to run through a list of numbers. Our iteration variable is named itervar, and while we do not use itervar in the loop, it does control the loop and cause the loop body to be executed once for each of the values in the list. In the body of the loop, we add 1 to the current value of count for each of the values in the list. While the loop is executing, the value of count is the same of values we have seen so far. Once the loop completes, the value of count is the total number of items. The total number falls in our lap at the end of the loop. We construct the loop so that we have the same construct the loop so that we have what we want then the loop when the loop finishes. Another similar loop that computes the total of a set of numbers is as follows. Total equals 0 for itervar in numbers. Total equals total plus itervar blah blah blah. In this loop we do use the iteration variable instead of adding. Okay, so for itervar. In this loop we do use the iteration variable instead of simply adding 1 to the count as in the previous loop, we add the actual number to the running total during each. Okay. Okay. We set the variable count to 0 before the loop starts. Then we write a for loop to run through the list of numbers. Our iteration variable is named itervar, and while we do not use itervar in the loop, it does control the loop and cause the loop body to be executed once for each of the values in the list. Okay, so it counts how many, okay, it took me so much time to figure out that it's supposed to count how many numbers are in this. Yeah, you really have to write. Yeah, if you write it for yourself and you see the result, it makes it more interactive. Oh, okay. In the body of the loop, we add 1 to the current value of count for each of the values in the list. While the loop is executing, the value of count is the number of values we have seen so far. Once the loop completes, the value of count is the total number of items. The total number falls in our lap at the end of the loop. We construct the loop so that we have what we want when the loop finishes. Another similar loop that computes the total of a set of numbers is as follows. Anyway, so yes, so this is the reference to the beginning, that we have a variable with a value, and in order for this loop to work, we change the previous variable by 1. But why do we do this? Why does this make sense? In the body of the loop, we add 1 to the current value of count for each of the values in the list. Okay, so if we would add 2, what would happen? So we would get 12. Wow, it's so much faster. But if I would put like zha. And if it's 0, then the count will be 0. So, okay. Maybe I understand. We add 1 to the current value of count for each of the values in the list. Okay. So, okay, but why do we need to, okay, whatever. I'm not gonna ask too many questions. I'm just gonna acknowledge that we created a value with 0. What if by initially I'm just gonna leave it 1? It will be, oh, okay, and what if I add 2 now? And 1 more. Okay, so yeah, it's gonna break it. Okay. Okay, I guess it makes sense. Let me just write this down. Ah, it's nice. Actually, it doesn't bullshit me now. Ah, it's nice. Actually, the code, when you insert it here, it actually looks like the actual code. That's actually very, very nice. That's amazing. Okay, so I'm gonna just write it here for my own sake. Control, so what was the reset? The Control N. I'm so sorry, no, please don't do this. So we declare the variable with 0 value. We declare the variable with 0 value. We need this. We need this. Okay, so what is this referencing to? Updating. This is we need this to have a variable and to be able to, meaning it has to exist before. You have to initialize it. So we are initializing it and we are incrementing it later. So we declare the variable with 0, but okay, so instead of calling we are initializing. Initialize. We initialize it with this simple statement. I'm gonna make this italic. And now here we use the for statement. The itervar is gonna be our iteration variable. You don't have to do this. Okay, I'm just gonna write it and then I'm gonna select it. I'm so pissed. We declare the variable count. Sorry. Our iteration variable is our iteration variable is itervar. It does control the loop and cause the loop body to be executed once for each value. And while we do not use itervar in the loop, it does control the loop. So what is the difference? Why would you say we are not using it in the loop? I thought when we are using the for, we are already, okay, I get it. Because we are using it at the beginning of the loop, which is called iteration. The iteration, okay. So iteration, yeah. So iteration itself is the beginning of the loop. Would you say that? Would you say that's true? Iteration is the beginning of the loop. I don't give a shit. So our iteration variable is itervar, and we are not using it in the loop, but it does control the loop and cause the loop body to be executed for each of the values. We are not using it later in the body. In the body of the loop, we add 1 to the current value of count for each of the values in the list. While the loop is executing, the value of count is the number of values we have seen so far. We add 1. So we are incrementing. I hate you so much. We incrementing our counts. We incrementing our count variable by 1, which will total equals 0 for iter var in 1, 2, 3, 4, 5, 6, total plus iter var. Okay, so see, so there is an option. See, so in this case, we don't actually have to add 1. Yeah, in this loop, we do use the iteration variable instead of simply adding 1 to the count. As in the previous loop, we add the actual number to the running total during each loop iteration. If you think about the variable total, it contains the running total of the values so far. So before the loop starts, total is 0 because we have not yet seen any values during the loop total is the running total. And the end of the loop total is the, oh my god. So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running total, and at the end of the loop, total is the overall total. Oh my goodness. Jesus Christ. Oh my goodness. This is a meme. This sentence here is a meme. Help. Send help.
So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running. So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running total, and at the end of the loop, total is the overall total of all the values in the list. So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running total, and at the end of the loop, total is the overall total of all the values in the list. Send help. If you think about the variable total, it contains the running total of the values so far. So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running total, and at the end of the loop, total is the overall total of all the values in the list. Send help.
Okay, we are having our break. It's okay. Ahoy. Sorry, I just have a. I'm studying, so I have no do not disturb on. But I'm using the Pomodoro technique, so 25 minutes and 5 minutes break. So it looks. The first picture is an adapter. I'm losing. Okay. So this first one, C, is an adapter. So you have a display port and you can insert. So I don't. And it only has. Okay, so I guess 4K monitors are not gonna use VGA cables. Okay, and yeah, and USB-C. I think you gave me a USB-C at some point. You did. You gave me a USB-C at some point. Yes. And I think this is from you. Yeah, yeah. Of course. I'm here. I'm just every 25 minutes. I want to like until 6. Focused. So I'm just not instantly because I will be. No, it's okay. Yeah, and if you're here, you can also just leave in case you're in. You're welcome. Take care.
Hey, if you think about the variable total, it hey, if you think about the variable total, it contains the running total of the values so far. So before the loop starts, total is 0 because we have not yet seen any values. Finish this line first. If you think about the variable total, it contains the running total of the values so far. So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running total, and at the end of the loop, total is the overall total of all the values in the list. Send help. If you think about the variable total, it contains the running total of the values so far. So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running total, and at the end of the loop, total is the overall total of all the values in the list. Send help. If you think about the variable total, it contains the running total of the values so far. So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running total, and at the end of the loop, total is the overall total of all the values in the list. Send help.
What got you into...
If you think about the variable total, it contains the running total of the values so far. So before the loop starts, total is 0 because we have not yet seen any values. During the loop, total is the running total, and at the end of the loop, total is the overall total of all the values in the list. If you think about the variable total.
Okay, very funny. Ha 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 ha. Very funny. Ha ha ha. So funny. Phew. Tivolka. Okay, we are getting there. We are getting there. A bit I lost my track of thought, but again, as I said, we have to really like it's gonna happen. You cannot escape that you lose your trail of thought. But what defines success in this is that you are able to get back no matter what. Like okay, I lost it. Okay, I'm getting back to it. And now I actually, here I'm getting some understandment. I cannot speak English anymore. So in this loop, we do use the iteration variable. Instead of simply adding one to the count, as in the previous loop, we add the actual number to the total running total during each loop iteration. If you think about the variable total, it contains the running total of the values so far. So before the loop starts, total is 0. Before the loop starts, total is 0, because we have not yet seen any values. And this is the initializing part. We are initializing total so it can exist, and we can affect it later in the code. During the loop, total is the running total. During the loop, total is the running total. What the fuck? During the loop, total is the running, and at the end of the loop, total is the overall total of all the values in the list. As the loop executes, total accumulates the sum of the elements. A variable used this way is sometimes called accumulator. Neither the counting loop nor the summing loop are particularly useful in practice because these are built-in functions, len and sum, that computes the number of items in a list, and then total, that is okay. So this is like a 42 type of example, is that we don't use this in life. You are just trying to teach me the logic. So you can use count plus 1, okay. Okay, I get it. So you don't really have to overthink this again. Because I didn't indent anything. What's the problem? So the 4 doesn't have to be after. Okay, sorry. In this loop, we do use the iteration variable. Instead of simply adding 1 to the count, we add the actual number to the okay. we add the actual number. So if we add all of these numbers together, it's gonna be 154. The running total. If you think about the variable total, it contains, okay, blah blah blah. As the lobby executes, total accumulates the sum of the elements. A variable used this way. Okay. Okay, I'm gonna just write this down. As the loop executes, total accumulates the sum of the elements. A variable is sometimes called an accumulator. To find the largest value in a list or sequence, we construct the following loop. Accumulator, 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 accumulator. To find the largest value in a list or sequence, we construct the following loop. Largest equals none. Print before largest for either var in if largest is none or yo. I don't think I have to really read it. When the program executes, the output is as follows. Okay, I'm just gonna write it down. To find the largest value in a list or sequence, we construct the following loop. When the program executes, the output is as follows. The variable largest, I'm gonna write it down and then I'm gonna read it. Why is it it's different color? Anyway. Okay, yeah. The variable largest is best thought of as the largest value we have seen so far. Before the loop, we set largest to the constant none. None is a special constant value which we can store in a variable to mark the variable as empty. Before the loop starts, the largest value we have seen so far is none, so we have not yet seen any values. While the loop is executing, if largest is none, then we take the first value we see as the largest so far. You can see in the first iteration when the value of iter_var is 0, since largest is none, we immediately set largest to be 3. After the first iteration, largest is no longer none, so the second part of the compound logical expression that checks iter_var largest triggers only when we see a value that is larger than the largest so far. When we see new even larger value, we take that new value for largest. Compound, yeah. Only when we see a value that is larger than the largest so far. When we see a new even larger value, we take that new value for largest. You can see in the program output that largest progresses from 3 to 41 to 74. At the end of the loop, we have scanned all of the values, and the variable largest now does contain the largest value in the list. To compute the smallest number, the code is very similar with one small change. Again, smallest is the smallest so far before, during, and after the loop executes. When the loop has completed, smallest contains the minimum value in the list. Again, as in counting and summing, the built-in functions max and min make writing these exact loops unnecessary. The following is a simple version of the Python built-in minimum function. See, so really like the key of learning the idea behind programming is that you understand built-in functions which are already so I mean we could actually do, I'm not gonna spend time learning C for now at all, but the idea actually it's nice that you create your own functions because you really get to know what's going on. The following is a simple version of Python built-in min function. Define min values. Smallest equals none for value in values. If smallest is none or value is the smallest, okay. In the function version of the smallest code, we removed all of the print statements so as to be equivalent to the min function, which is already built into Python. Debugging. As you start writing bigger programs, you might find yourself more codes mean more chance to make an error and more places for bugs to hide. One way to cut your debugging time is debugging by bisection. For example, if there are 100 lines in your program and you check one at a time, it would take 100 steps. Instead, try to break the program in half. Look at the middle of the program or near it. For an intermediate value, you can check add print statement or something else. Okay. Yada yada yada, yada yada yada. Before the loop, we set largest to the constant none. I don't mean to do this. Before the loop, we set it to a constant. None is a special. Okay. Before the loop starts, the largest value we have seen so far. Okay, wait. So we set it, yeah, as an empty. It's gonna be a condition, special constant value, special constant value. While the loop is executing, if largest is none. Okay, wait, I don't know what's going on. Before the loop starts, larger, yeah, we have not yet. While the loop is executing, if largest is none, then we take the first value we see as the largest so far. You can see in the first iteration when the value of itervar is 3, since largest is none, we immediately set largest to be 3. After the first iteration, largest is no longer none, so the second part of the compound logical expression that checks itervar largest triggers only when we see a value that is larger than the largest seen so far. If largest is none or itervar is larger than largest. So we create this before. So we know that, okay, if largest is none or itervar is largest equals itervar. There was a way to replace all. Was it F5? No. Replace all, change all variables name. Okay, excuse me, can I leave? Thank you. No, I knew I did this before. How do you do that? Maybe I should put it in the. Oh my god, I was not supposed to share this shit. Okay, nobody cares. Yeah, 5 minutes of rest. La la la. La la la. La 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 la. So basically we had the peak really at 3:30, but it was actually really nice. I really felt it. I really felt like when I was describing this part, I really felt like, okay, now my brain is working. But the problem is it's such a short-lived feeling. But it's such a short-lived, I would say. But yeah, it should still. Now you have to put the effort of paying attention. So what I wanted to do is just change this. So how can I change variable but all? Change all occurrences. See? So that's it. F2. Control F2. Smallest is the smallest so far. Okay, so okay, so the code doesn't work because we didn't change it, but we just gonna have to change this too. So very small change. Okay, so just to explain the logic, so we initialize the variable and it's gonna equal to none. So it means that the value is going to be the smallest possible. We're going to print it, so it will show that the largest number currently is 0. And wait, so this, yeah. Then we're going to use our iteration variable to define the numbers we are having, or what numbers are we going to use. And then we have this condition. So we basically create the loop here. If the largest is none, or whatever in this bracket here is the largest is gonna become the iteration variable. And we're gonna, print loop. So what is the loop here doing? Is it gonna be in there? It's just a string. Yeah, it's the string. Okay, never mind. So that's it. And this is the same logic here. Yeah, I guess I get this. Initialize. We initialize our variable. We initialize our variable largest. Then we start a for loop and use our iteration You should actually make this for yourself, right? Like, how can I make this into a function? That's gonna be the question. Like, hey, make a function from this. Min. So we are using, yeah, for value in values. Okay, again, yeah, so this is our parameter, right? And this is referring to the volume. Yeah, this is still. So in this case, yeah. Okay. So our iteration variable is the values. And then again, this is exactly, it's gonna be the same. Just different thing. If smallest, so if smallest is none, or value is Control F2. Okay, but not here. I just want to do it. Okay, wait a second. Never mind, I'm back. So I will have to like comment this out. But I think maybe it will still. Okay. Control plus Shift with down. Control Shift A. It's not working. Sorry, Shift Alt A, I'm sorry. Okay. Okay, so it's gonna be Control F2, but it's still gonna select it. Still gonna change it. So Control F2, VS Code, Control F2, leave, select comment, do not touch. whatever. Okay, so our value is our iteration variable. So now we rewritten and we have our thingy in a function, but now we have to know how to use this function again. And what we had, okay, I'm gonna like check back like on our computer. I'm gonna have to use a reference. Define, so now we can create a program compute pay. So that's it. Is there any difference between these brackets? I don't know what's going on. Compute pay, okay. one way to cut your debugging by section. If example there are, instead try to break the problem in half, look at the middle of the program or near it for an intermediate value you can check, add a print statement or something else that has a verifiable effect and run the program. If the midpoint check is incorrect, the problem must be in the first half of the program. If it is correct, the problem is in the second half. Each time you perform a check like this, you have the number of lines you have to search. After 6 steps, which is much less than 100, you would be down to 1 or 2 lines of code, at least in theory. In practice, it is not always clear what the middle of the program is, and not always possible to check it. It doesn't make sense to count the lines and find the exact midpoint. Instead, think about places in the program where there might be errors and places where it's easy to put a check. Then choose a spot where you think the chances are about the same that the bug is before or after the check. Write a program which repeatedly reads integers until the user enters done. Once done is entered, print out the total count and average of the integers. If the user enters anything other than integers, detect their mistake using try and except and print out error message. It's okay. We're gonna just we're just gonna copy paste it from other code which we already did before. Write a program which repeatedly reads integers until the user enters done. So this is something should be already familiar to us, because yes, the Gehi. It reads integers until the user enters done. So let's really use pen and paper. Pen and paper, what can we do? So write a program which until the user enters done. So definitely we need to use so you need to break. We're gonna use the break. That's like the end. That's one of the things we have to do. Repeatedly reach integers. So yeah, you are making it hard for yourself by doing the bullshit. So line input. So while true. Yeah, we can start with this while true. And it has to be integer, so not floating, so we can even like float it. So What's going on? I think it's so if I create here something, it will create plain text. Yeah, sucks to be you. Do you wanna go out and put hair on my clothes? You can do that. So while true, God damn it, man. God damn it. Okay, calm down. Write a program which repeatedly reads integers until the user enters done. If done is entered, print out the total count. Okay. So we could maybe have I could use the built-in function, right? And what kind of do we have a list of functions, built-in functions? After done is entered, print out the total, count, and average of the integers. Something happened here. Because I changed it. Yeah, I know what you mean. Counting and sum. So print out total as iteration. None of these are the built-in len and sum that computes the number of items in a list and total items in the list respectively. So sum is gonna be the total. We're gonna use the sum. Sorry. We're gonna use the count. So how many numbers? It's gonna be the len, right? But do we have to import? Or is it already, like, do I have to like import it? Because we defined the function here, but if I don't define, do I have to import it before I can I use okay. Okay, so what can I use for the average? Okay, I guess this is like so we can use sum and length is the like both of them at the same time. Okay, we have an input here definitely, and we don't have to make it a number here now, or not yet. And so okay, so this is, so do we need to what would be the, I mean, we are not even creating separate functions because we're already gonna use the built-in ones. So let's say yes, so we're gonna add while true if line, okay, so it will keep continue. I could use function in a function. So, fú, úristen, úristen. It hurts to think. It literally hurts. It hurts to think, man. It hurts to pain. It's painful. So painful. Phew. Jaj, nagyon rossz. I don't like this. I don't like this at all. I don't like this. Break time. Yeah, break time. Okay. Let's see. If I will try again, I will record again.